After studying the PV array block in the last simulation and last training, let's go to a new tutorial about series and parallel connection of PV panel in Matlab Simulink. The learning outcomes of this tutorial will be to be able to study the different configuration of a PV panel in Matlab Simulink and use series and parallel connection of PV module simulated in Matlab Simulink. This is the last circuit that we have studied in the last tutorial. We have the PV panel block, and we have the inputs of irradiance and temperature, and the different equipment for measurements. The current measurement, the voltage measurement, the load, the product block, and the display block. The objective of this tutorial is to implement various PV array with the same characteristic in series and in parallel. Let's do that together. To do that, we have to implement a new PV array and to connect the different PV array in series and in parallel. Let's firstly do a copy paste of this PV block, click in control and take the block below. This is the first one. Let's pass a new one. Positive terminal is connected with negative terminal of the next PV array, etc. We connect the positive terminal of the third PV array with the negative terminal of the second, the positive terminal of the second with the negative terminal of the first. Then for the load, the positive terminal is connected with the current measurements and then connected with the load. For the last negative terminal, which will be connected with the load to close the circuit. That's it, the circuit. Different components or the different PV arrays are connected in series. Let's also connect the input for different array. Let's work with the same constant. For example, we can connect the irradiance with the same value as input for the first PV array. Also, for the second or the third PV array, we can connect the same value of irradiation. It's the same for temperature. The second with the same temperature, and the third with the same temperature. Let's start the simulation. To start the simulation, press run. It will take some time to be simulated. Here is the result of the simulation after starting the simulation. So we get this value of current, power, and voltage. The current is about 5.5 amps, 119 watts, and 21.5 volt. This is in a configuration of PV panels in parallel, in series, sorry. This is the configuration of PV panels in series. If, for example, we change the value, if you want, for example, to choose to modify and to work on a specific input and to see the effect of this input on the parameter, electrical parameter, you can select, double click on irradiance and select, for example, 800 watts per square meter. Actually, the power is about 119 for 1000 watts per square meter. Let's simulate for 800 watts per square meter. Start the simulation. It take also some second to be simulated. Depending on the stop time that you choose, you can select different value as your simulation. It's 3D. Here is the value when we select an input of 800 watts per square meter. It's very low compared with the first value. This is the simulation for serial connection of PV panel. About the value of the load. When we are working and when we have worked with just one panel, to calculate the switchable load, so we have divided the value of voltage divided by the value of current, means the resistance that you have to insert in this resistance is the voltage value divided by the current value. Actually, we have 3 panels in series. To have and to get the value of resistance, it's the same that we have 3 resistance in parallel. That means that the value of the resistance will be the value of resistance of module 1, product of value of resistance 2, product of resistance 3, to get the value of the load for your resistance. Let's go to the second simulation. In the second simulation, we are going to simulate the 3 PV panels in parallel. To do that, we have to connect the positive terminal together and the negative terminal together. Connecting the positive terminal with the positive terminal of the third PV panel with the positive terminal. Also, the same for negative terminal to get 2 negative, 1 negative, and 1 positive. Then we will connect the positive terminal with the current measurement and the negative terminal with the load. Actually, the 3 panels are connected in parallel. Let's switch to the standard test conditions, press OK, and start the simulation with the same condition, just with difference with the second configuration, which is the 3 PV panels in parallel. Start simulation. Here is a problem, voltage measurement block. So the voltage measurement is not connected. So we have to connect the voltage measurement block. Okay, restart the simulation. Here is the value of the power. Here is the value of the voltage, and here is the value of the current. The current is almost the multiple of the value of the voltage in one module, and the voltage is the same voltage that is in the in the PV panel number 1, number 2, and number 3. It's the same voltage, and the summation or the addition of the value of for the current. Let's also simulate, for example, a value of low irradiation, for example, 100. Start simulation to see the results. Here is the simulation: low power, low current, and low voltage, because the value of the radiation is low if compared to the first value. Let's also work, for example, with low value of the temperature. Actually, the value of power is 273. Let's work, for example, with 20 degrees Celsius. Start simulation. Remember with me, 73. Start simulation. The value of the value of the power is 260, less than the aforementioned value. But when we work with low temperature, we have to find an increase in the value of the power. Let's work with high value, for example, 40 value. Start simulation. The value of the power is about 323. I think there is some problem in this configuration. This is the question for you. If you could find the problem in the simulation, it's very interesting because there is something missing in this simulation. I will give you the chance to respond and to comment on the problem on the simulation. Why, when we increase the temperature, also the power increase, and when we decrease the value of temperature, the power decrease, because really it's not the same. There is the correlation with irradiance, but not with the value of temperature. Thank you for your attention. Let me your comments and see you later.